The James Webb Telescope has proved to be a game changer, ever since it was launched into space. Every day NASA releases impressive fresh findings from the telescope as if the massive space is just waiting to be explored and new things are eager to be discovered. It's like we're on the verge of uncovering something monumental that would alter our reality, from making the world skeptical about the Great Big Bang Theory to revealing magnificent images of sweeping galaxies. The James Webb Telescope is changing how we see the world. The enormity of the universe is simply beyond human comprehension. Did you know that just in 2016 they were estimated to be about 2 trillion galaxies in the observable universe, and what do these galaxies hold within themselves? Or secrets are buried within the unfathomable abyss of the universe? Perhaps we will never know just how expansive space is. However, technological advancements like the James Webb Hubble have broadened our horizons to a great extent, considering the mind-boggling revelations of these iconic telescopes. We have managed to figure out that inside the immense vastness of the universe lie great mysteries. No wonder the space so extensive that it's littered with countless enigmas. And a multitude of perplexing things, and scientists have recently made a momentous discovery. Join us as we tell you how NASA just revealed an image of mysterious object that seemingly arrived from another solar system. Like something you've never seen before, the second known object to have traveled outside of our solar system. And 2I Borisov has been revealed in never-before-seen images by NASA. A distant spiral galaxy can be seen off to the side of the comet in the picture. But the image's bright blue center, which the Hubble Space Telescope captured as it followed the comet through space, draws attention to it. The image depicts the comet as it travels through our solar system on its way back to interstellar space, where it once was. Gennady Borisov, an amateur astronomer, first spotted a moving object on August 30, 2019. While looking upward through his homemade telescope, this wandering point of light, now known as 2I Borisov, turned out to be the first confirmed comet and second foreign object to visit our solar system from a region outside the influence of our Sun. Astronomers from all over the world rushed to look at the object with some of the most potent tools available to learn as much as possible about the intriguing visitor. Astronomers have discovered that 2I Borisov has an unusual composition due to observations made with the Hubble Space Telescope and the Atacama Large Millimeter Sub-Millimeter Array ELMA of the National Radio Astronomy Observatory. In particular, it contains more carbon monoxide than any comet observed at a relative distance, or within about 300 million kilometers of the Sun, though other types of stars are possible. Scientists suggest the comet may have formed around a red dwarf, a smaller, fainter type of star than our Sun. Another hypothesis is that 2I Borisov is a small planet fragment rich in carbon monoxide. Comets are ice dust and frozen gas snowballs. They're roughly the size of a small town when completely frozen or inactive, but when heated by the Sun their ends can stretch for millions of miles. 2I Borisov is approximately 9 football fields in length, or 0.98 kilometers. Nature Astronomy has published the most recent findings regarding the comet's makeup. All comets originate in the early material disk surrounding a developing star, preserving traces of the planetary systems distant past the history of the element that went into creating Earth and our other planetary neighbors, including water, as revealed by comets from our own solar neighborhood. On the other hand, an interstellar comet is a chemical messenger from a completely different star system and holds a wealth of information about worlds that are too far away for space travel. In October and December of 2019, the comet 2I Borisov was photographed by NASA's Hubble Space Telescope as it sped through our solar system at an incredible speed of about 177,000 kilometers per hour. A bright nucleus was visible in the images, but the nucleus itself was too small for Hubble to see. Hubble images taken in March 2020 revealed a stark change in the comet's appearance rather than the comets previously observed. Single bright in a core, the images suggested a small portion had cracked away from the nucleus. Scientists will still use Hubble to keep an eye on the comet. Borisov spread like wildfire throughout the world. Following a week of worldwide observations by amateur and expert astronomers, researchers were able to trace the path of the darting visitor and confirm its extrasolar origin. Scientist Bodwitz and his associates used Hubble to observe 2I Borisov between December the 11th, 2019 and January the 13th, 2020. Separately, on December 15th and 16, 2019, a group of international researchers under the direction of Martin Cordina and Stephanie Milham in NASA's Goddard Space Flight Center in Greenbelt, Maryland, observed the comet using ALMA, a network of radio telescopes located in northern Chile for the height of 16,570 feet. The cold, low-energy gas in things like comets can be seen using radio telescopes. A high carbon monoxide to water ratio indicates that the comet initially came from an icy region that is on par with the Kuiper Belt, which is the region where Pluto is connected to our Sun. According to the Hubble using team's theory, a red dwarf, the most prevalent kind of star in the Milky Way, may have served as the starting point for 2I Borisov. The planet-forming material surrounding red dwarfs would be colder than the elements that make up our solar system, because they are smaller and less bright than the Sun. The low temperatures and luminosities of these stars are ideal for forming comets with the kind of constituents found in comet 2I Borisov, but no matter what kind of star 2I Borisov originated from, scientists using ALMA speculate that it may have been a piece of a dwarf planet with a lot of carbon monoxide close to its surface, and according to experts, the fragments rich in carbon monoxide could be released into space if that object collided with another. The ALMA team notes that 2I Borisov may have simply developed as a comet with a high carbon monoxide content. Alternatively, it might have an exceptionally thick layer outside that protects frozen gases like water and hydrogen cyanide. It may seem more plentiful than other cometary gases, as the more flammable carbon monoxide vaporizes or outgases. The peculiar characteristics of Borisov may also point to a greater variety of carbon monoxide in comets than was previously believed. In our solar system, whatever the solution, 2I Borisov throws a whole new set of challenges into the way of cometary research. The Odd Cloud, which is much farther away, and the Kuiper Belt, which includes Pluto. The two regions in our solar system where most comets have failed. All of these comets probably originated closer to the Sun, but they might have been pushed farther from it by the erratic motions of Saturn and Jupiter billions of years ago, and due to these massive planets' powerful gravitational pull, comets may have even been launched away from the Sun and toward other stars. Given this background, researchers using Hubble hypothesized that 2I Borisov may have been thrown our way by a giant planets in a red dwarf system that existed in a climate with frozen carbon monoxide. Bodwitz believes that if a planet the size of Jupiter moved inward, it could eject many of these comets. The ALMA team agrees that the comet was likely sent on his way by a young moving planet. They claim that 2I Borisov built its brief encounter with our solar system after a chilly, lonesome journey, at which point he began to emit gases and reveal its interior to us. According to Hubble and ALMA findings, 2I Borisov has a higher carbon monoxide content than most comets in the solar system. Borisov is drifting away from our Sun quickly and will eventually re-enter interstellar space, never to leave again. Comet Borisov's trajectory is being slightly altered by the Sun's gravity, but due to the comet's path and high velocity, it cannot be captured and pulled into orbit. Unlike our Sun and its family of planets, Borisov was born in a different star system. It might be younger or older than our 4.5 billion years old planetary system. Most of the time, gravitational interactions with the Jupiter have caused comets that were first formed around our Sun to be released from our solar system. So it's plausible that Borisov was also similarly expelled from its home system. We have not directly observed a Borisov surface, but comets from our own solar system have rough surfaces occasionally covered in smooth layers of ice and dusty debris. Borisov is too small to maintain its own atmosphere because it lacks sufficient material or mass, and as a result, gravity. However, Borisov has developed a coma, a dust-filled cloud of gas surrounding the comet's nucleus. A coma is formed when ice is heated by solar energy and dust brushes off the comet's surface and into space. Professor of Astronomy and Planetary Science, the University of California, Los Angeles, David Jewett, whose team captured the best and sharpest images of this first interstellar comet, explained that the Hubble provides the most accurate estimation of the nucleus's size, which is the most crucial component of comet Borisov. Their Hubble images reveal that its nucleus is considerably smaller than earlier research had hypothesized, almost 15 times smaller. The radius is not more than 500 meters, significant because figuring out the size allows them to estimate the total number and mass of these objects in the Milky Way and the solar system. Since Borisov is the only interstellar comet observed, they'd like to learn how many more. There are only one other extracellular visitor, officially known as Oumuamua, was discovered in 2017. It sped out of the solar system after passing the Sun at a distance of 24 million miles. Due to its lightning speed, scientists couldn't gather much information about it. It is still unclear to scientists whether it was an asteroid comet or possibly a combination of the two, despite it being initially labeled as a comet. Observations after it sped past the Sun on September 9, 2017 at a blinding speed of 87.3 kilometers per second revealed no evidence of cometary activity, before more recent measurements showed it was slightly accelerating, indicating it acts more like an asteroid. It was again categorized as a comet. Now that they have seen two mysterious interstellar objects, scientists hope to see more and compare them to those